Good day, everyone. I'm Miss Romulo, and I'm the first reporter of the Group 10, and I'm going to discuss about the Chapter 10, and the title of the chapter is all about statistics and computer tools for analyzing of assessment data. So for most educators, just hearing the term statistics conjure images causing anxiety, even to those educators who do not consider themselves numerically deficient. Statistics intimidates them. In descriptive statistics, which will be the focus of discussion in this chapter, the emphasis is on describing a set of scores. Description may take the form of tables, graphs, or as a single number, for example, an average. In this chapter, the basic concepts of statistics, the relevant statistical treatment that can facilitate the interpretation and analysis of data, as well as the use of computer as aid in analyzing and data presentation will be covered. At the end of this chapter, you should be able to first utilize process data and results in reporting, and lastly, interpreting learners' performance. Many teachers think that statistics requires advanced mathematical skills and tedious calculations. The elementary statistical concepts necessary in organization, interpretation, analysis, and presentation for evaluation of grades and scores of students is not what majority thinks of. At present, not only calculators are at hand to facilitate computations, but most especially computers and some software which are available for statistical computation and treatment. The statistics that is discussed in this chapter is descriptive in nature, and brief overview of inferential statistics is given. The three types of statistical measures covered in this chapter are measures of central tendency, measures of variations, and measures of relationship. The statistical treatment for individual data subject to interpretation is also covered in this chapter. So, the fir- uh, what is statistics? Statistics is concerned with the organization, analysis, and interpretation of test scores and other numerical data. Statistical techniques help teachers to analyze and describe results of measurement obtained in their own classrooms, understand the statistics used in test manuals and research reports, and interpret the various types of derived scores used in assessment. Statistical methods enable us to look at information from a small collection of people or items and make inferences about a larger collection of people or items. Procedures for analyzing data, together with rules of inference, are central topics in the study of statistics. Brace and Brace 2012 defines statistics as the duty of how to collect, organize, analyze, and interpret numerical information from data, and that is statistics. Second, we have the descriptive and inferential statistics. Descriptive statistics, this is used to describe a group of individuals or describe the data that have been collected, to describe variables that were grouped in order to determine the measure of certain dependent variable that needs to be measured. Various data analysis techniques provide meaningful description of scores with small number of numerical indices. Such indices are calculated using samples drawn from a population and are called statistics. On the other hand, when indices are calculated using the entire population, it is called parameters. This type of statistics is used for summarizing and describing data sets. While inferential statistics, it is when there is a need to make a decision, estimate prediction, or generalize about a population based on a sample. Then inferential statistics will be utilized. There are two types of tests in inferential statistics. These types are the parametric and non-parametric. In parametric test, a test of significance is used if the data represent an interval or ratio scale of measurement and other assumptions have been met. On the other hand, non-parametric test is used when data represent an ordinal or nominal scale, when a parametric assumption has been greatly violated, or when the nature of the distribution is not known. Third, we have the statistical tools. To carry out meaningful comparisons among sets of test scores, a statistical tool is needed. Measures of central tendency and measures of variability are the most commonly used statistical tools. So here we have the measures of central tendency and its characteristics. First, we have the mean. Its first of the mean characteristics are most frequently used index of distribution central tendency. Second, it is simply an arithmetic average of all the scores in the distribution. Third, since it is computed using every score in the distribution, it is an extremely representative measure. Lastly, its strength is also its weakness because several atypically high or atypically low scores, sometimes called liars, can distort the value of the mean. Next, we have the median. Its first characteristic of the median is the second most frequently used index of central tendency. Next, it is the point that divides the scores into two equal halves. And next, one advantage of median as a measure of central tendency is that it is not unduly affected by peculiarly large or small scores. Next, unlike the mean, the median treats each of these wild scores as merely another score, no more, no less than other scores. Lastly, as the mean, the median strength is also its weakness. The median fails to reflect the magnitude of the impact of every score in the distribution, even when certain of those scores are very high or very low. Lastly, we have the mode. It is the most frequently occurring score in the distribution. With most reasonably large set of scores, the mode will occur somewhere near the middle of the distribution, so it can also serve as an index of the distribution's central tendency. In some cases, a distribution has two or even three most frequently occurring scores. In such cases, statisticians refer to it as bimodal or trimodal distribution. Multimodal distribution refers to those with three or more frequently occurring scores. And lastly, since the mode takes into account even fewer data than the median and fewer than the mean, it is not used often in describing a distribution's central tendency. I think that is all my part. Thank you for listening, and the next reporter will continue the lesson.
Hello everyone, so let's continue the chapter 10, the measures of variability. Aside from describing how a set of scores tends to the center of distribution, the information about how variables the score are is also important. It is also relevant to know how to spread out the scores are. So, the measures of variability and characteristics. First is the range. Range, it has three characteristics. First, most readily calculated index of distribution's variability. Second, it is calculated subtracting the lowest score from the highest score. Third, the simplicity of the range computation is just only the redeeming virtue because there are only two scores involved in its computation. If there is an abnormally highest and or lowest score, the resulting range will yield a misleading indication of the distribution's overall variability. Second, second measures of variability is the quartile deviation. Quartile deviation, it is based on the range of the middle 50% of the scores instead of the range of the entire set. It is semi-interquartile range. Quartile points are on the scale like averages and percentiles. The quartile deviation represents a distance on the scale. It indicates the distance that is necessary to go above and below the median to include approximately the middle of 50% of the scores. Semi-interquartile is the half of the quartile. Third measures of variability is the standard deviation. It has 5 characteristics. First, it offers a way of thinking about the average variability of a set of scores when they compute the mean. It tells the average distance from the mean for each of the scores in the distribution. Third, the more spread out of the scores are, the larger the value of the standard deviation. The less spread out the scores, the smaller the standard deviation is. It is the most useful measure of variability because it takes into account the amount that each score deviates from the mean. It is more stable measure of variability than the others. In summary, the quartile deviation is used with median and is reasonable for analyzing small number of scores. These statistics are obtained by counting and thus are not affected by the value of each score. They are especially useful when one or more scores deviate markedly from the others in the set of scores. On the other hand, the standard deviation is used with the mean. It is a most reliable measure of variability and it is especially useful in testing. Also, it is useful in describing the set of scores in a group. It serves as basis for computing standard score, the standard error of measurement, and other statistics used in analyzing and interpreting scores.
Hello everyone, I am Charis Jane Baklir Kimno from BS in Mathematics and I am here to discuss to you about the part 3 of chapter 10.
To work with numbers, they should speak the same language. For example, if we are describing some results after taking 3 separate tests, the following data doesn't mean anything for you. Test 1.
Completed the test in 3 minutes.
Test 2. With no mistakes. Test 3. 30 question answered. Instead, we will say, based on the test results, the person has an IQ
Of 100.
So standard score is a set of scores that have the same mean and standard deviation, so they can be compared. Let's do a short recap. When we say mean, it is the average of all the scores and in the very center of a plotted graphs of scores.
Standard deviation is a measure of how dispersed the data is in relation to the mean.
This is the normal distribution of data or the Gaussian distribution. So if we have a high or large standard deviation, so it indicates that the data are more spread out. And if we have a low or small standard deviation, it indicates that the data are clustered tightly around the mean. This is how standard deviation affects the normal distribution. So there are another group of standard scores that may be used in assessment. First of that is the z-score. Z-score is the simplest of the standard scores and the one on which others are based. So it expresses the performance simply and directly as the number of standard deviation units a row score is above or below the mean. Positive z-score says the data point is above average, and negative z-score says that the data point is below average. A z-score is always negative when the row score is smaller than the mean. Thus, a z-score is seldom used indirectly in a test norms, but are transformed into a standard score system that uses only positive numbers. Let's learn more about the z-score. So the formula getting the z-score is equal to x minus mu over standard deviation, wherein x is the score and mu is the mean. This means that this part here, from here to here, is part of the general population. But the question is, what percentage of the general population have IQs larger than 130? So this means that our answer here is from here to here. So another standard score is the t-score. So t-score is the equivalent to number of standard deviation away from the mean of the t-distribution. So it refers to any set of normal distributed standard scores that has a mean of 50 in a standard deviation of 10. So t-score is obtained by multiplying the z-score by 10 and adding the product to 50. T-score is preferred than z-scores for reporting test results because it's only produced positive integers. Next up is the Stanines, from the word standard 9. It is a method of scaling test scores on a 9-point standard scale. So these are simple type of normalized standard score that illustrate the process of normalization. So the following are the major strengths of Stanines. First is that the Stanine system uses a 9-point scale in which 9 is high, 1 is low, and 5 is average. Second is that Stanines are normalized standard scores that make it possible to compare students' performance on various assessments. Third, it makes easy to combine different types of data because it is computed as a percentile ranks but are expressed in standard score form. And it is easy to record because it uses a single digit score and it takes up less space than other scores. The last standard score that can be used in assessment is the percentile rank. So according to Lin and Gronlund 2000, percentile rank indicates students' relative position in a group in terms of percentage of students scoring lower. So one of the most widely used and easily understood methods of describing assessment performance. So this is how it looks like, the percentile rank. The 50th is the mean or the average rank. There are techniques of describing the relationships of the scores in different subject areas. These are the graphic presentation, the product moment correlation coefficient, and the rank order correlation coefficient. First is the graphic presentation. By using graphic display techniques, the relationships between two variables can be described according to its magnitude, or strong or weak, and its direction, which is positive or negative. This technique, though, shows that it is difficult to get a firm grasp on graphically displayed relationship.
Let's learn first what is correlation.
So, what is correlation? So, correlation is a measure to determine the degree of two sets of variables x and y. So, for instance, if you are looking if the height of a person affects its weight, so this is an example of correlation. So, our x here is the height, which is the independent variable, and Ry is the weight, which is dependent variable. Spearman's rank relation. So Spearman's rank relation was developed by Charles Spearman, denoted as P or Rho. So P is a Greek letter P. So it is used to study the strength of association between two ranked variables. So Spearman's rank relation is used in ordinal set of numbers. So when we say ordinal set of numbers, this is in which a variable can be arranged in order, one after another, so that the ranks can be given to each. So Spearman's rank relation assesses monotonic relationship. So when we say monotonic relationship, it is when, say, if the value of one variable increases, so does the other variable, or as the value of another variable increases, the other
Let's know first what
variable
is correlation.
decreases. So in the figures below, various samples and their corresponding sample correlation coefficient values are presented. The first three represent the extreme monotonic correlation values of -1, 0, and 1. Next is the product moment correlation, popularly known as Pearson correlation coefficient, or R, named after the English statistician Carl Pearson. So it ranges from +1 to -1, and R of +1 is implies perfect perfect positive relationship, while the -1 implies perfect negative relationship, and 0 implies no linear relationship that exists between two variables. The correlation approach is used with linearly related data, meaning data whose scatter plots shows a more or less straight line relationship.
Good day everyone, I am Glenn Sason from the BE Ed second year, and this is my report. My report is all about computer aid in statistical computing and data presentation. Okay, so in the previous paragraphs of this chapter, fundamental concepts of statistics and statistical tools used for different statistical methods were discussed. So in the succeeding paragraph, simple computations of statistical treatment will be discussed with emphasis on the use of computers, since our topic is all about computer and the software MS Excel, or known sa to as Excel. So an MS Excel is a software developed by Microsoft to make computation more efficient and less prone to errors. So let's now move on to the next slide. Okay, so now we will know what are the basic steps in opening the MS Excel program, or kabalo naman ta ani since naghimo na tag data analysis. Okay, so number one, so as you can see in the picture na circle diha, click the icon of the MS Excel, or if not available, then click the start button to choose all programs and double click on MS Excel to open the program. So this is the initial window that will appear, and if you are using the latest version of the MS Excel, simply click on blank document options. If you have a previously created file to work on, or napakigibuhat atong last, then simply double click and then open other worksheets. Okay, so now let us move on to the number 2. So as you can see in the picture, once a worksheet has been opened, or kung na-open na siya, since kita niyo diha nanay sulat ang atong worksheet, then it is now ready for data entry. And then you may now encode the scores or the data that will be processed. So the worksheet is like this. So just like sa makita sa picture. So if na-open na, and then now we may start encoding our data. So pwede na mag-encode sa mga scores and data nga na-gather. So we start a discussion with charts and frequency distribution. Okay, so next is the charts and frequency distribution. So as you can see in the table contains the grades of 10 students. And then in the table contains the grades of 10 students in their mathematics and English subjects. So the first column is the student class number, and then okay, nyo makita diha 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the second column is the math grade, or ilang grades sa math, and then the third column is the English grade. Okay, so and then the next picture is all about using data so it may be converted into charts and or diagrams. So just like in sa picture kaya nakagather na mga information, so it may be converted into charts or into diagrams. So a scatter diagram was created by using the insert chart function of MS Excel. So detailed steps on how to have scatter diagrams are as follows. So the next picture will be the detailed steps on how to have scatter diagrams. Okay, so number 1 is that you have to click the insert tab. So kanang circle lang diha nadapit ang insert tab. Then among the chart options, choose insert scatter. So you have to choose the insert scatter. So note that the other types of chart may be chosen based on preference of the user and how they would want to present their data. So bar graphs, pwede po bar graphs, and then pie charts, line graphs, and etc. So are just some of the charts that are available and can be utilized. Okay, so now let us move on to the next picture. So now we are here in the computing for the measures of central tendency, variability, and correlation. So statistical functions are available in MS Excel. So available, you can siya nito sa Excel. So you just have to click the formulas tab, and the different available formula logically organized will be displayed. Okay, so choose the more functions icon. So pangitaon nimo tong more functions, and then choose statistical. So several statistical formula are provided on the list. So for the mean, the function average will be used. Okay, so mo ni ang base ganiha. So kato akong giingon ganiha is mo ni siya ang katong sa first picture. So mo ni siya ang katong statistical functions that are available in MS Excel. And then next is this second picture is example nagyapon siya. So for the mean, you have to choose the average from the list, and then once you click the function average, the following screen will be displayed. So once mo na siya ni-click, then it will automatically displayed. Okay, so but by the way, na pa ko i-explain nga last. Okay, so actually that mo to siya ang mga basic steps para maka-learn ta on how to use the MS Excel. So you have to pareha na pud ani nga picture pareha na pud ani nga mga pictures inyo nakita. Then you just have to fill in the required fields to indicate which among the encoded data will be considered in the computation of the mean, and then you have to press the OK, and automatically the mean will be computed and placed on the space where you indicated to place the result for this case. So the once enclosed with rounded edge box. So for example, if na-click ninyo, then mamili ra ka kung aha butang ang result. So similar steps shall be followed for other statistical formulas such as the standard deviation, or known as the STDEV, and then the median, the mode, the range, the person, and then the z-test. Same user interface is displayed, so it is easier for the user to encode the necessary information such as the raw data that will be included in the processing or the computation. Okay, so not all may be available in MS Excel, but nevertheless, majority of those statistical computations are. So although dili man tanan, but then naaragid na siya. So in the older version of the MS Excel, the statistical formula are not available. So sa old version patong Excel, dili pa siya available. So instead, most of the formula are packaged all together and displayed into a single table containing the computed values. So this is packaged under descriptive statistics function and statistics summary. Okay, so the information contained in the package function consists of the following. So just like what I said earlier, the mean, the median, median, mode, the standard deviation, sample variance, kurtosis, skewness, range, minimum, maximum, sum, and count. So another software that was really designed to support statistical computations is the SPSS. So or statistical package for social sciences. So I know we are familiar with this software. It's because ng data analysis natin, and Ma'am Hinovia told us that mo ni siya po ang usa ka way para nota if reliable ba ang ato ang mga information na gather or data na gathered, so which has evolved into statistical product and service solutions. So all the statistical formula are available in this software. Okay, so mo na to akong report, and thank you for listening.